Okay. All right, on the next page, again, we have another hexagonal prism. I gave you another one because odds are you will have to do that again on your test. Volume of a prism is capital B, which means the area of the base, times the height. We have to remember that this is a regular polygon, and to get the area of the base, you're going to have to do the apothegm times perimeter times 2. The apothegm was given to us. It's our distance from the center to the side. So that's the 10.4 that it's pointing to. And now I just need to find the perimeter of the hexagon. This 12 here represents the side of the hexagon. So if I'm going all the way around, each side is 12. There's 6 sides. So basically I'm doing 6 times 12, or just add up 12 6 times, and I get 72. So I'm going to multiply those together, then divide by 2. So our B, our area of base, ends up becoming 374.4. So to get to the volume, we now are just going to plug into our formula. We know the base is the 374.4. The height is our distance between the bases. That was our 4 over there. So go ahead. That's what you're multiplying together. I hope you see that's a 4. And you can do that off the cell phone or the calculator or whatever. I'm not giving you the final answer to this. It is in the thousands. Okay. All right, number 8. Again, we want to write the volume of a prism. This is a triangular prism because our base, we have 2 congruent bases, 2 faces that are congruent, which are the triangles. So volume is area of the base times height. Our base is a triangle, which means base times height divided by 2. That height in the triangle is different from the height of the prism. The height of the triangle goes from the base up to the top of the vertex. This is our base. So because I see that, I have 4, and over there, right here, this was 4, so this is 4, this is equilateral. This now turns into a 60, 30, 90 triangle. So the height of my triangle, because the base gets cut into 2, becomes 2 radical 3. So we're going to do 2 radical 3 times the whole base, which was 4, and divide by 2. Our base here, our B, ends up becoming 4 square root of 3. So we know the height is the distance between our triangles, our bases. So for our volume, we're taking that 4 square root of 3, which is our base. We're multiplying by that 11. Just to recap, which can be multiplied together, the 11 and the 4, that's 44. Then we add the radical 3. That would be meters cubed. I know I recognized, I probably forgot the units on the other ones. So that's that question. Then you had, they wanted the volume of the solid created with a cone and cylinder. So basically, they want you to take the volume of the cone plus, they want to take the volume of the cylinder. Volume of the cone, that's the 1/3 BH. Volume of the cylinder, that's just the BH. B is the area of the base. And our base for the cone and the cylinder is a circle, which is pi r squared. Our radius is 5, so that's the same radius of the cone, which would be 5. So B is really, if I do 5 squared, you're absolutely right, 25 pi. And our height of our cone, the height of the cone goes from the base of the cone, or the center, up to the vertex. So this is missing. And this is kind of similar to what we did on the first page. What am I going to have to do here to find, let me help you, I'll put that box so maybe you can see it a little bit better, to find the height. If you said Pythagorean theorem, you're absolutely correct. So we're going to end up having to do a squared plus b squared equals c squared to get our height. Now notice our height is one of the legs, which is h, plus b squared equals 13 squared. So we're actually kind of end up going to subtract. I'm going to let you try to see if you get to the answer. And hopefully you got the height to be 12. So now that you know those parts, we're just going to plug it in. This is going to be 1/3 our 25 pi plus the 12. That's for the cone. And I kind of ran out of room here. Apologize. Or I could say 25 pi times 12 divided by 3. This ends up being 100 pi. Okay. And then I'm going to add on my cylinder. My cylinder is the area of the base, which is at 25 pi, times the height of the cylinder, which is the 20 pi. So that ends up being 500 pi. And then we just add them together. I probably should have showed you that, but I think you can do this. And then here we have the volume of a pyramid. Volume of the pyramid is like volume of cone, so we're doing area of the base times the height. I think you can take care of this. Just in case you're not sure, the base is this rectangle. How do we find the area of a rectangle? That's base times height, or length times width. Basically, we're going to be doing 7 by 6. Okay? And then the height of our pyramid is exactly that. I believe that's 8. This distance here, our h is 8. And we're just plugging it in and getting the answer. I know you could do that. Now, I'm definitely going to talk about 11. 11 won't be on the test, but it's a good test to make sure you know what you're doing. So please read the questions on your test to make sure you're following what the question is asked. This is what is the height of the right cylinder with the radius of 4, that's important. And the volume of 224 pi, that's important. So we're trying to find what the height is. Okay, and we're talking about volume. Volume of a cylinder, that's important too, is base times height. Well, in a cylinder, our base is a circle, so that's basically pi r squared. I already know what the volume is. It's at 224, so I'm going to substitute the v with that. 224 pi equals the pi r squared times the height. Well, we know the radius too. That's 4. So 224 pi is equal to pi times 4 squared times the height. We're trying to find the height, so we're going to have to work backwards here. Well, 4 squared is 16 pi, then times my height. Well, now all I have to do now is divide by that 16 pi. The pi's will cancel each other out, and I'll get the height. The height is 14. So on 12, you're working backwards again, but I want to do this with you because we're talking about a cone. And it says the volume of the cone is 156 pi. Find the radius if the base of the height of the base if the height is 13. So volume of a cone, this is when we're doing 1/3 BH. This is why I want to talk about this, because we still need to work on working backwards in our algebra scales. Our V is the 156 pi, because they gave us the volume. We're still going to do 1/3. Excuse me, I might sneeze again. The B, that's the area of the base. I don't know what that is because I don't know what the radius is. So I don't know B, but I do know the height, which is 13. So I know B represents the circle, which is pi r squared. But if I could just solve for B, then I could figure out that radius. Because if I know my B, for example, is 100, then the radius has to be 10, because 10 squared. If I know my B, for example, is 25, then the radius has to be 5, because 5 squared is 25. So we got to get this B by itself. To do that, because we have this 1/3 here, we're going to multiply everything, both sides, by 3. The opposite of taking a third or dividing by 3 is multiplying by 3. So that's going to cancel out the 1/3. And now I'm doing 3 times 156, so we get 468 pi equals basically 13 times B. Well, to get the B by itself, which is what I want to do so I can get to my radius, I'm going to divide by 13. And so I divide by 13, I get 36 equals my B, which I know is pi r squared. And so what would our radius be in a case like that? Okay, I think you got it. All right, and then we had a trapezoidal. I know this writing is off. It says, what is the volume of a right cone? No, we don't have a cone underneath here. We're just trying to find the volume of this trapezoidal prism. I hope you saw that that's what it is, which means the bases are trapezoids. So the volume is BH. To do the area of a base, which is a trapezoid, this is our formula: 1/2 B1 plus B2 times the height. Our bases are a top and bottom, or our parallel sides. So this is a base, which is the same as 12 there, so that's 12. And here is a base, 7. These two sides are parallel to each other. So we're going to do 7 plus 12 times the height. Our height is the distance between the bases, the perpendicular distance, which is the 6.5. And we're taking a half of that. Order of operations is we're going to add these together first. So 19 times 6.5. Half of that would mean we're dividing by 2. So our base is 61.75. So I know the height of my prism is our distance between our bases, which is 16. So basically I'm taking that 61.75, which was my area of my base, times it by the 16, which is the height of the prism, 988 feet cubed. Alright, the next video will talk about similar figures, so I'm going to walk through those as well. And then the test questions, the practice test questions, are for you to do. I am not going to videotape those, but I will be checking it for your grade. Alright, thanks for taking care of this set. Go on to the next video.